Hello, so essentially I'm an automation guy, so I do control systems such as PLCs and the electrical system, usually revolving around the PLC, but not necessarily, and the instrumentation also usually revolving around PLC. So a lot of my bread and butter actually comes from this instrument called a PLC, programmable logic controller. So what I've been doing during the lockdown is I'm been writing a compiler, PLC compiler, that converts the ladder representation of a PLC diagram, which would conform to the IE61131, and then I would convert, or then I'm converting that to some C code, and then the C code I'm converting to machine code. Well, that bit, the C code to machine code, I'm actually not doing that. I've got a third-party package actually doing that. So essentially, this is a cross compiler. So what you've got in front of you is the representation of a ladder diagram. So this line of text over here would be one rung of code, and below it I've just briefly put in, this is what it would look like, something like this, say examine if closed, and in this particular case I've set it to be always true, and that's the output I'm driving, which is a physical output here. I've got a development board here which is running a Texas Instruments microprocessor called the AM6548 processor, very powerful processor. Anyway, so this here in front of you is representation of a ladder diagram. So I haven't done the front GUI end of it. So let's just take that off there. So essentially I can compile this, and I've written the compiler in C++, and this is Visual Studio 2019. The package that I've got in front of you, and this is just one of the files in the PLC that is represented in front of you over here. So this is actually not part of the package. This is an external file that I'm just using this IDE as an editor. That's all I'm doing, just to make life easy for myself. So I can actually compile this. So I compile it over here. There you see it's just compiled, and I've got sort of a lot of information here chucking around. So just to show you, so if you look at the first rung over here, where my mouse is, T on output, there it is over here, T on and it does a whole lot of stuff. Although this is actually not an error, I should change it, or I will change this error data. That's not true. I need to change it. But anyway, so that's what it does, and it does every single one, all the way down, okay, until the end basically. So let's get rid of that. So that's now converted that code into some C code, and the C code looks like this. So here's that first rung you looked at. Here it is. So you can see some resemblance to the source code and this C code over here. So that's the C code. Now this C code gets imported or exported, depending on your point of view, into a package called Code Composer Studio, which is a Texas Instruments package, which is this package over here. Sorry if I'm speaking fast, but I'll try and keep this video as short as possible. And here's the Code Composer Studio, and this is a Texas Instruments package, and I'm running a real-time operating system over here called sys/BIOS, also supplied by Texas Instruments. So this has typical things like interrupts, tasks, time slices, schedules, events, all this type of stuff sits within this package over here. So this is essentially the PLC operating system. I can then get that, and just to show that that this does also compile. So in other words, that C code that the other package generated, the Visual Studio 2019, is actually a legit C code, and it's imported, like I said, automatically. So I'll build this project over here, which is in front of us, and so there's some of the code there. So that's what it's actually building, this as well. So this is what we've imported. So let's have a look and see if it's been built. So pompems, as I say in some countries. So it's build, finish, there we go. And we go here, problems, no problems, wonderful. So I can switch the board on, and I can then essentially download this to the target. And the target is, like I said, an AM6548. Now let's relaunch the communication driver, for want of a better word. It's actually a little bit more than that. Okay, so it's launching the communication driver, and then we get the communication driver, and it does some initialization of the board over here that you can see in front of you. Very sophisticated chip, AM6548. You Google it, it's, you know, something special, I tell you. Okay, so it's managed to connect to the device by virtue that I've got this over here. Then I get the software that I've compiled, and this is, I know it's over there, so okay, and I run the thing. So it's breakpoint at the main over here, and I can run that, and I've actually got a board that I'm not showing you on the screen over here, but 5 seconds later a light comes on, poof, there we go, and 4.5 seconds later, boom, the other light comes on. There you go. So it's actually working. So I can do a timer in this thing, and the timer obviously sits in the real-time operating system. So I can do as many timers as I want, really. You know, it's just a question of how much memory do I have. So I've left it at the timer bit. I mean, I'm doing the normal examine if open, examine if close, the timer on, I've done that. But because I can do the timer on, I just developed a way of passing a struct piece of information to the timer. So as you would have in a Siemens PLC, it would be in a data block, you know, for example. It may be in Allen Bradley, it'd be a user-defined data. So I can do that. All that sort of wonderful mechanisms of the PLC sit there. So that's what I've been doing. So thanks for watching, and stay safe, and good luck. Ciao.